Good morning, good afternoon, good evening, depending on where you are in the world. My name is Hugh Morris. I'm a senior research partner here at Zien, and it's my absolute pleasure to be able to chair this event today. Now, I can only do this thanks to the generosity of our sponsors, who allow us to range widely and freely across a whole series of topics around technology, economics, and finance. So my job is to get out of the way as fast as possible and introduce you to the main event. Please note that the slides will be available to download after the session, and use the chat facility to send in your questions to me, and I will submit those. As you can see, following my introduction, our guest speaker, David Tuppen, will deliver what, having looked at the slides, is a fabulous presentation, and we will then have plenty of time for questions after that. So, without further ado, David, the floor is yours. Thank you.
Thank you very much. If we can get, there we go. Can everyone see the deck? Can you see the deck there?
I can.
So hey guys, so my name's David Tuppen. I'm head of data and analytics at GFT. And what I'm going to talk about today is the evolution of the modern data platform. So that's the end-to-end approach on how to design a platform in today's changing markets. I'm going to break this presentation into three different sections. So first, I'm going to talk about data analytics and thinking differently, and looking at and giving you a case study that looked at data differently and how to store and process data differently and what the outcomes were. I'm then going to walk through the evolution of the data platform, where it started, where we are now, and then looking at the modern data platform, where we are at this point in time. So thinking differently, social analytics. We don't like to think of ourselves as boring, but we are. We are creatures of habit. Once in a while, we break free of those habits, but the main behavior is very predictable. So that was said by Dr. Alex Pentland, working at MIT. What he meant by this is I actually had a study which looked at social analytics and human behavior. What they found was 95% of our time, we follow a set path. So what I mean is, we wake up in the morning, we have breakfast, we drive to work, we have lunch, we drive home, we may walk the dog, we go to the shop, and then we come home. And if you look at that little map below, that's what I mean by our set path. 95% of our time shows our normal behaviors. 5% of our time, we forage. And what I mean by forage is, we drive a new route, we may go to a different lunch spot, we may go to the pharmacy, we can go buy some clothes, we'll go to the cinema, we take our partners out for drinks and dinner, and then we come home. That 5%, known as foraging, is actually a sign of good health. So if we're exploring and we're investigating, that's in our nature. We should be doing that. The absence of this indicates something is wrong. So we'll revert back to common usual paths when something's up. So that could be, health-wise, or we within financial duress. This is all interesting, but so how do you use that information? So what do you do with that? So MIT actually partnered with TD Bank in Canada. And what they wanted to do was apply this logic of ill health. How do you determine ill health to a case study? So what they did was typical credit decisioning. They looked at that, right? So if you want to go get some credit and take out a loan, what do? They look at your past payment history. Have you taken out credit? Yes, you have. Have you made your payments? Yes or no? If you've missed payments, your credit rating goes up and down. That's based on historic data. But what happens if you know you're going to lose your job tomorrow, and for the next 6 months, you're not going to have any income because you're looking for other work and whatnot? Someone may go out and go look for apply for a loan or additional credits, but they actually have no intention of paying that back. Historic data is not going to tell us. Historic data is just going to tell us that we made payments in the past. So how can we predict that we'll be able to make those payments? Well, with what they actually did at MIT, was they analyzed the movements of individuals. They did a case study of, if I'm not mistaken, it was about 4,000 people with TD Bank. They tracked the information from people's mobile devices, their phones, stored that information, processed it, and generated predictions based on that 5% of foraging. If people were foraging and investigating and going out and spending money and looking and going outside their normal path, they knew nothing was wrong. These guys look like they can pay it back. That reduction in foraging, that reduction in 5%, then showed them, well, hold on a second, there's something up. This person's not going to be able to pay it back. And the results were crazy. So, I mean, the study that was done showed 10 times higher accuracy than looking at traditional methods, which included demographics and credit ratings. So really think about that. Looking at historic data gave us a certain understanding, but looking at a more modern approach to data gave us a more accurate result set. So what did we do here? We created a modern data platform. So these results were only accessible by streaming data in, by storing that data, by modeling the data differently, and then creating insights from that data. So before I jump into what does a modern data platform look like, what is the evolution of how have we gotten here? The starting way back when, everyone would have known about this, right? Before big data, before everything else. We look at number one. Everyone knows about the Access database challenge and the Excel spreadsheet database that everyone still has. So this is where we had a user and their source data was a plethora of different text files and CSVs and whatnot. They import that within, for instance, Excel. From Excel, they may have a macro running in the background, and that macro then generates additional data that you can go create another tab and go look at your reports. This is still done today and historically was done for ages, right? The challenge with this is, of course, scalability, integrity of your data, locking, security, accessibility of your data, and the list goes on. So what did we come up with? We started looking at, well, how do we remove that data and create an optimized store for your data? And this is where the data warehouse comes into play. Now, back in the day, I mean, if I'm not mistaken, I could be wrong, it was the 1970s where the data warehousing term was first pegged. What does that mean? So this is where we were debating over Kimball, dimensional modeling versus NMON, third normal form versus data vault. We weren't looking at necessarily new technology. We were looking at how to model the data differently to optimally get the data out, right? How do you store it? How do you process it to get that data out? In some cases, we created data marts, and in some cases, we went straight to the data warehouse. But the idea here is that the application, which would have been whatever it is, Excel, Access, whatever that is, would then schedule the data out, pass that through to a data warehouse. From the data warehouse, you create data marts and then create insights. Now, going back, let's say 15 years, 10 years, the question behind how to do this was really only SQL Server versus Oracle, Kimball versus NMON. SQL Server has one single feature and Oracle actually has this feature. MySQL or Teradata with MPP. These were the types of debates that we were having rather than where we are now. And that's where we have our technology explosion, as it were, within the industry. So no longer are we debating of SQL versus Oracle. You can kind of put them in the same bucket nowadays. We're looking at big data, NoSQL, structured, unstructured, data lakes, data stacks, columnar, the list goes on. The technologies that we can use nowadays is endless, right? BigQuery, Palantir, Kafka, MongoDB, Synapse, CockroachDB, MarkLogic, Hadoop, Snowflake, and how to use those is all in question. Now, if you look at the two different diagrams at the top, when you've got 3 and then 4, we started with looking at, well, data lakes came out, and how do we utilize data lakes? Now, there's one stream of thought where you can schedule a data into a data lake, so you can get that data in there really quickly, and then from there, create slices of that data that you can harmonize into your data warehouse. You can create data marts on top of that then and do insights as you normally would. Alternatively, you can model everything again and move that into your data warehouse. Now, the challenge with this, and I should have mentioned, I apologize on the diagram before at number 3, is the challenge with a data warehouse is that to create an entire data warehouse in its entirety, it's a lengthy process. You have to model the entire scope of what's needed for the business before they can start using it. So if a data warehouse takes 2 years to model, the business have to wait for that data warehouse to be complete. So that monolithic design, as everyone is calling it nowadays, takes time. And data silos are created on the outskirts, and therefore, when it's actually complete, people aren't using the data warehouse. And that's where you have a lot of failed data warehouse projects. Now, this approach with the data lake doesn't address that. It addresses the fact that we can get in any data in any format within one layer very quickly. But if you want to actually still create that data warehouse for your optimal reporting, you still have to slice that out and actually create that design. So then we look at number 4. So we've moved on now. We're going, well, hold on a second. We're not really, this is not better because we still need to create this model inside the data warehouse. So what can we do? Oh, I don't know. We can remove the data warehouse altogether. And this is a new idea that's still fresh in the market, is let's create a lake house. So what we do, and also here, is instead of scheduling that data into your data lake, we got a lot of focus on, well, let's start streaming the data in. Let's not wait till the end of the day. Let's stream that directly into our lake house, which is a data lake essentially with changes on top of it, and create data assets and data services on top of that. So what's the challenge with this architecture now that we've moved the data warehouse? Data warehouse is traditionally relational and structured. It's designed in a way to optimally get your data out. So to bypass that within your data lake, you have to remove the SQL-like functions to get the data fast, or reduce the amount of data that you actually need within those data services. And that's where you create your data assets and your data services to be able to generate your insights. What's the challenge with this? Let's say you have a customer name within your lake house, and that customer name is spread across different data services. If that customer name changes and you have 1,000 data services and data assets, you are going to have to reprocess 1,000 data assets to make sure that that name is replicated, and then generate insights off it. So although on paper it looks fantastic, let's just stream it into a data lake. We'll track the changes inside of it. We can actually create a model inside there. We're bypassing the benefits of what we see from other architectures and design patterns. So where does that take us now? So we used to have a data warehouse. We've decided, okay, it's too slow. We can't wait 2 years. Let's try to get all the data into one store, which is your data lake. But that data warehouse is still taking too long. So let's get rid of it altogether, and let's just use a lake house. But now we've removed the optimal reporting layer. So we'll reduce all the data down into your data services. But now we have to replicate all the data. So what do we do? And that's where we start moving into what is the modern data platform. Before I show you that point of view, what are the analysts predicting when considering modern data platforms? So by 2025, smart workflows and seamless interactions among humans and machines will likely be a standard as a corporate balance sheet, and most employees will use data to optimize nearly every aspect of their work. You can't, this is true, but you can't automate all of this, much like I said in the beginning, without having that platform in place. You need that modern data platform in order to do all of this. So if by 2025, this is what we're looking at, smart workflows and seamless interactions, we need that modern data platform in place. And what McKinsey are saying is, to get there, just like I've said, you need a modernized data architecture. That's saying you need to be able to treat data as a product, not the asset, not just the service. Treat it as a product, an holistic, a multitude of assets generate that product. Start looking at value from your data. Look more into real time. Now, I did mention that's we're moving towards the streaming. I'm not saying to get rid of batch, but I'll speak about that in a second within the architecture. Consider data marketplaces and data ecosystems, and this is where we start looking at trading information within your organization and externally, gaining value from data products and trading them between business units so that you gain additional value. Automating data management through privacy, security, and resiliency, and then embedding data within every decision within your organization. McKinsey note 5 different steps on how to get there. That is use a road-tested blueprint architecture. treat your data, deploy in an MVP, minimal viable product. Don't look for the monolith redesign and mega design that's going to take 2 years. Let's look at a domain and deploy that. Prepare your business for change. It's not technology first. Educate your business, train them, communicate, manage their expectations. And then also look at your actual team structure. Split your team between as a data engineering organization. So that's looking at a data platform team, which is engineers, architects, and modelers. And then your insights team, your products team, which is your data scientists and your analysts. So what does that look like as an architecture? So if we look to the right and you look at the key themes that are within the architecture in the left, which I'll go through in a second. It's treating data as a product. It's creating that layer for data marketplace. Domain level architecture. What this is splitting up the architecture so that you're not looking at a mega design, or again, that frequently used word, monolith. Front to back design. This is where you look at what the customer wants and working backwards, as opposed to what IT and technology want to design and working the way forward to the business. Metadata management. This is understanding what you have. This is automating the approach to the attributes and critical data elements that you have available and servicing them up to the business. Enhanced stream-driven processing. This is, again, not getting rid of batch processing. This is applying stream when it's necessary. This is not having to wait till the end of the day, but if you need to wait, then you create the batch. It's when to use which is the point. The main benefit that you'll get from all of this is you focus on creating incremental value, which shows a regular return on investment. So what does that architecture then look like? If I break this down into 3 major layers, which I think most it'll resonate with most. You have your data sources and systems of records. You have your storage and processing layer, and then you have your systems of engagement. So if we focus on the storage and processing, what's the difference here to, you'll see the top right-hand corner, I mentioned them before again, that's where we are. This is where we start splitting up, and we don't isolate and say, right, we're going to get rid of something and add something and get rid of something. We break that layer down into, and again, this will resonate with the audience. We flow data in through a unified raw zone, landing zone. We create that data so that it can be used in a plethora of different ways, and then we distribute and manage that data. Now, each one of those layers can be broken down into different architectural design patterns. So if we look at a domain level architecture, where you see there's those first 2 blocks there, domain 1 and domain 2, we're not creating a mega design. We are creating a strip of data within a domain. So that you can think of it like, if I want to create a domain for finance as opposed to risk, and create risk in isolation as a domain, we can create data products per one of those and then deploy those in isolation. And again, that goes back to what McKinsey's saying about a minimal viable product. It may not be as minimal as the size of a large scale domain like finance, but you're creating a domain level architecture that you can deploy, and that finance don't have to wait for risk before something is ready. Am I saying to get rid of the legacy big data platform? Of course not. You can't. Organizations have now built this, and we're dependent on it. So we can enrich the capability. Maybe we need a data warehouse. Maybe we need a data lake. I'm not saying that we'd have to redesign everything to create the domain level architecture. The difference with the evolution so far is that by number 4, where we've said just start dropping persistent data warehouses, just start dropping what we don't need, rather start incorporating what actually is needed across the evolution. If we need a data lake, let's start using it. If we need a data warehouse, let's start using it. But incorporate that into your design strategy. So if you need to create a domain level architecture that incorporates a data lake and a data warehouse and an ODS that may exist within it, you can do that within your domain and then surface that up as a data product. From that data product, you can then surface that up within your systems of engagement, which is your data services, data fabric, and data marketplace. From your data marketplace, you can trade that information, right? And again, this is going back to, I've got a data product for finance, I've got a data product for risk. I don't want to have to recreate the wheel for each one of these. So what do those look like? And within that data marketplace, you can start creating integrity ratings on those data products and see what the data quality may be like. And you can pick and choose what you want to actually start trading on. A high quality data product may be of best use, and therefore you pick one over the other. You can then pass those products down into your visualization layer. And the idea here is that you are not restricting any business unit from their own technology. If one business unit wants to use Click and another one uses Tableau, then maybe another one wants to use Power BI, you allow them to do that, but you centralize that through your data marketplace. They access a report from the company-wide marketplace, as opposed to disparate URLs all over the place, and where you create that silo effect. This is a lot to take in, and this is a multitude of layers of design within architecture, and can certainly not be covered within 20 minutes, which would need a deep dive into each one of these. But at a high level, what do you really need to consider to create this architecture? So I said before, the modern data platform is evolving. You focus on incremental value, showing regular ROI, as opposed to costly mega redesigns. Next year, there will be something else to add to a modern data platform, and that is still coming. There's no golden hammer that's going to resolve the entire modern data platform. So focus on where you want to get to. What do you want to achieve? And that's where we look at one of the key themes, and what McKinsey are talking about. Work front to back, understand what your customer wants, and then build an architecture that suits what they need, as opposed to putting IT and technology first and then working your way forward. So again, if you start at ground zero and you need a data warehouse, you look at, do they need optimal reporting? Do they need fast slice and dice capability? Do they need to be able to drilling down into their data? Or maybe they do need that. If they don't need that, and what they need are data assets, structured data sets, so they can put them into their ML models or forecasting models, then don't go away and create a holistic data model for that. Create a structured approach to fast generation of data assets and then data products. And that's where it comes to, where would you want to be? What will generate the most value for the business? Don't focus on the new shiny tech. So assess where you are, where you want to be, and don't boil the ocean. Don't try to create the holistic modern data platform when you don't need the entirety of it. Transform your landscape. And this is from technical design to people management. It's critical that you understand, and as McKinsey noted, it's critical to train and communicate with your staff to mature their data literacy within the organization. Goes without saying, we need to manage and we need to govern. There are different governance methodologies nowadays in the market. And again, this is further than a 20-minute presentation, but we can have domain level architecture. We can have democratized architecture governance. We can have a unified layer of governance, and it really depends on a plethora of reasons why you do that. And then lastly, monetize from the design that you're putting together. The business want to see that we are generating revenue. Don't do tech just for tech. Show value from what you're putting together and what architecture you've developed. So that's within my time limit. I'm going to pause there. We are at 23 minutes, so I'll hand over. I know that was very fast, but we've got a tight timeline, so I will hand over for any questions.
David, that was fabulous. Thank you so much. A genuine whistle-stop tour of a truly fascinating and a subject that we would happily spend weeks on. So thank you very much indeed for that. So yeah, now is the opportunity to relay to you questions from the audience. First question from Dan Feeney. Did the TD Bank research to which you referred happen before COVID? And perhaps leading on from that, how has COVID changed data, the way people go foraging?
Wow, really good question. It did happen. It happened in, I can't give you the exact year. I just know about the time that I heard Alex Penton actually talk about it, which was 2017 it was. So it was pre-COVID. And I would imagine, I mean, your spending and your habits obviously would change during COVID. No one could leave their house, right? So I think everyone would look like their usual pattern. You'd have to start looking at different channels in terms of signs of good health, right? So that's I might hazard a guess you're investigating online and tracking of what you're doing, you know, from home. But it's a good question. It's not going to work if all you can do is sit inside your room, right?
And is there an observable change that people have done in terms of the way they're foraging or the percentage of time that they're foraging?
Unfortunately, I wouldn't. I haven't followed up on
Okay.
on the social analytics of it, but I would imagine so. You know, everything has changed since COVID. But yeah.
Cool. So the next question I've got is from Clive Bullen, who asks clearly a very pertinent question. Is there a danger of the processes becoming too complicated for most employees of an organization, and hence a higher chance of errors and poor outputs, to more of the sort of garbage in, garbage out syndrome?
100%. 100%. And that's a fantastic question. So I think it was in 2016, Gartner raised a term called a data swamp. A data swamp is because, you know, much like he said, the complexity now changes, right? Everyone wants to use the new shiny tech, and therefore it'll solve all your problems. What happened was everyone was dumping their data inside of a data lake and generating what's termed now as a data swamp, because the data became unusable. With all these different technologies and architectural patterns that have come out, that's why I really push on the fact that do not try to create an holistic architecture that looks at domain level architecture, data lakes, data warehouse, ODSs, data marts, data marketplace. Look at what the business needs, start from front to back, and create that slice of the architecture that they actually need. Start with a data strategy, not with a technology strategy. That's really important. Yep.
Cool. We also have a very understandable cri de coeur from Andrew House saying, what advice do you have for a non-technical business individual to know enough to add value in this area? So if people are moving into this from a non-technical background, how would they engage?
And that's where you, again, and also a good question, we shouldn't start a conversation with this is an architectural techie design, right? It should lead with business value. And that's where we start looking, again, it's going from front to back. It's working with your business, looking at what they want to achieve. It's not about, I want a data warehouse. It's, I have these reports that I need access to. I need to be able to drill down into it. It needs to be really quick. I need to get my data every half day. And then it's up to the technologist and the consultant to create an architecture that suits those functions. It's not up to the business to get to a low level of you know, a technical conversation. It's up to them to understand what exactly they want to achieve. And it's up to consultants like myself to be able to create that architecture in the background without them having to worry about the fact that the modern data platform changes every year. I hope that answers the question.
Thank you. And perhaps a slightly cheeky one from me, Dave. So your modern data platform that you mentioned looks to me to still show a fairly legacy big data architecture sitting in it. Is that not still a monolithic endeavor that you still need to have in place, or which again runs a bit counter to your very wise counsel about, you know, be nimble, generate short-term results, because that's the way people keep the faith?
Really good question. Yeah, so I knew that would come up. So what you need to take on board is that any one of those architectures, if you look at the legacy big data platform, that platform can still be embedded within a domain level architecture. So you can still have a data lake, data warehouse, data marts, or ODS within a domain that generates a data product. You don't have to generate, as I said before, I used the example of finance and risk. You don't have to create a data lake for a company of finance and risk, and then a data warehouse of finance and risk, and then a reporting layer and managed data layer for that. You can create a finance data lake with a data warehouse and a data product specifically for finance in its entirety. So in isolation, I mean. So instead of creating an holistic mega design across the organization, you create domain level, which can incorporate the technology stack and capabilities within the legacy, well, not legacy, traditional big data architecture.
Very good, thank you. A really interesting question from Stephen Mix. For startups or younger businesses that do not yet know what the pertinent data is to focus on, how do you approach creating a data platform that is capable of evolving?
Again, and that goes back to, it's what you should be aiming for, right? And that goes back to what they want to achieve, and what their own personal data strategy or business strategy needs to be. I say this because if we look at, let's say it's a startup, let's say it's a company that doesn't have too much of a budget, but they want to be able to get the data and harmonize it and create and gain benefits from it over the next 3 years. Now, generally speaking, 15 years ago, we would have said, well, let's go create a data warehouse and we'll spend the next two years building on it. The challenge with that data warehouse is of course trying to change it as time goes on to meet the business needs. What you have to do, it's a fine line between using latest tech and using latest design patterns versus what they actually need. What we don't want to do for a new business is create a platform that's over-engineered with the idea that, don't worry, we can be scalable enough that we can change over the next as and when we need. If the business isn't going to change that often, then we need to start looking at a different design pattern. There's no right or wrong answer here in terms of what to use. You may need a data warehouse. A data lake and data assets purely may work for you, but it really just depends on the business strategy and where you're going. There's no right and wrong answer. As I said in that last slide, there's no golden hammer to make this work for everyone. It really does change per organization.
I've got two questions from Ahmet Al-Akati. The first one says banks, and for banks reads, I think large information intense businesses tend to be risk averse. And I'm going to change this question very slightly. What do you think provides the impetus for large conservative organizations to sort of break out of the monolithic approach and be able to see the advantages of taking the more structured or broken down structure approach that you're advocating, where you don't say the interconnectedness of everything means you have to boil the ocean?
Yeah. Is the question how? So sorry, I missed the actual question part.
So the question is, or the way I'm phrasing it, is what would cause those big conservative institutions to sort of see the light and therefore be able to take a radically different approach from the way their traditional IT department would set about tackling the issue that you're describing?
Yeah, and in my opinion, it's ROI, right? It's that return on investment. It's iterative approach to design. The challenge with the data warehouse, it took 2-3 years, and everyone knows about them failing. We then moved into data lakes. And we really didn't, in my opinion, solve the problem. We just put everything inside there, hoping for the best because we got all the data in there really quickly. So therefore, now it's magically going to solve everything. It didn't, and we still need to somehow structure and model the data to get it out, and then optimize, a store that isn't there for data extraction in a fast manner. It really comes down to how do we achieve that return on investment quicker. And that's where we start creating the slices of data, the slices of domain and slices of those data products that we can then start surfacing up sooner, show that they're working, and then turning those off within the mega design, right? Within that, again, it's that the monolith approach. Now, whether that monolith is a poorly designed data warehouse, whether it's a data lake or whatever it's going to be, it's trying to switch off those capabilities and show that ROI within that domain level deployment. That's the major benefit here. Is not adding to what you have right now, but separating it out and proving that investment return to the business. And that's what they're going to be primarily after, right? How is this benefiting us? How are we saving money? How are we making money from when you start monetizing on that value from those domains? I hope that
Well,
answers that.
you and Ahmed are a perfect double act, because his second question is, how do you calculate ROI?
And that's a good question too, right? The challenge with that is, once you've deployed it, this is obviously the function, the specific function within the mega design or the monolith. In isolation within the design is going to be less expensive than the domain that you've just created, right? In monetary values, because you've had to redesign the whole domain. The value that you're going to get over time is when you start creating more and more domains, as opposed to one single domain versus what you just turned off inside the mega design. It's a fine line between which domain to choose to show the business that ROI sooner. In my opinion, when it comes to which domain to choose to show that capability, I would look at something that has the biggest impact on, I would say, the mega design or the monolith first, as opposed to a quick win, because that quick win will be more expensive in the end. But yeah, how do I define ROI? It can be a monetary value. It can be a people time that's spent actually developing it. It can be including the automation piece within that domain structure, so that you're not spending manual time developing and watching the mega design that keeps on falling over. So there's a plethora of characteristics that you can define as the ROI.
Thank you very much. And I guess a further question is a bit related to a previous one. Do you envisage that in your future idealized structure, or as on the journey to, that data warehouses and data lakes are still part of the landscape, or would you see them essentially being retired at some point during the journey to the outcome that you're recommending?
I think everyone's too quick to jump on what's dying now, so that the next best golden hammer can come along, to be honest. I think if you look past, I think the reason why everyone thinks that data warehouses are dead is because of incorrect implementation of them, incorrect modeling of them. When they're done correctly, they're fantastic. And when I say correctly, I don't just mean technically correctly. I mean delivering value to the customer base fast, and not having to wait for again that 2-3 year period before they actually receive that value. It's just not possible nowadays. Are data lakes gone? Of course not. You don't always need a data warehouse. You don't always have to model all the data within a company, so that your customer base and that's internal customer base get certain pieces of data. Is again, if your customer base and your internal staff want data assets, data sets of data, and have no intention of having to slice and dice and draw through to different data, and they're not bothered about optimized reporting, and they want to use that as input data into ML models or forecasting models, then why would you create a data warehouse for within a certain data model to have to get the data in there? Why not just create that input data for them? So I don't believe any of it's going to essentially die. I think it's going to evolve over time into different structures, and that's what we're seeing right now.
And perhaps one last question then. Given that the journey starts with a single step, in terms of what would you do on Monday morning, where would you make a start? And are there any particular technologies that you would say are best able to help you make a start, so that you can actually get on the journey to some short-term value delivery and get away from the monolithic approach?
If I was called in Monday morning to a new client, and they said they wanted us to assess their architecture, the very first thing I would do is sit down with whoever's going to be consuming and using the data, and find out what they want to do with that data. I would not go in saying you need this modern data platform, and it's going to solve all your problems. I want to understand exactly what they want to do, and I'll create we'll create a solution that aligns to that. Now, when I say a solution, I mean a data strategy, and the modern data platform is a strategy in place design patterns on how to store and process and access and trade that data. Technology strategy comes afterwards, and I would never walk into a client site and say you should be using X technology. I'd need to find out first what they want to be doing, and then I'll say, well, these technologies are options for you in order to create and align with that data strategy.
Super.
Yes.
Thank you, David.
No,
great stuff. I would offer thanks to all sorts of people for this. First of all, absolutely thanks to our sponsors who have made this possible. Really, really interesting session. Second, thank you to the audience for your attention and questions during this excellent session. And critically, of course, David, thank you so much for your time and your expertise in sharing it with our audience today. Very, very much appreciated.
No problem. Thank you very much.
We would very much like to offer you the opportunity to attend future webinars, and you can see on the screen now the next 4, all of which look to have serious interest, and I hope that you'll be able to attend. Amongst which the launch of the Global Financial Centers Index 32, which, as you know, is Zien's twice yearly survey of financial centers around the world, but they're all outstanding. Thank you, everybody. Really enjoyed your participation today, and see you soon.
Thank you.